We have a habit of looking at our species and patting ourselves on the back. By our own earthly metrics, humanity is a highly advanced civilization. We figured out how to split the atom, harnessing the building blocks of matter itself to generate staggering amounts of power. We've extended our senses across millions of miles of vacuum, dropping robotic rovers onto the surface of Mars with pinpoint precision. And we've wired the globe with a digital infrastructure that can process and share massive amounts of information in milliseconds. Because we string these victories together, we assume we're nearing the pinnacle of technology. But we're measuring our progress strictly against our own past. We aren't grading ourselves against the actual physical limits of the universe. When you compare the brief blink of human history to the scale of the cosmos, that earthly yardstick breaks down entirely. Humanity calls itself advanced. The universe disagrees. In 1964, Soviet astrophysicist Nikolai Kardashev proposed an objective way to measure a civilization's true level of advancement. He realized that things like microchips and rocket fuel are arbitrary human inventions. If you want a universal metric, one that applies to any species anywhere, you have to look at the raw physical capacity to harness and control energy. This diagram illustrates a Type 1 civilization. A species at this stage can capture and utilize 100% of the available energy on its home planet. We're talking about an output of roughly 10 to the 16th watts of power. A Type 2 civilization moves beyond its homeworld to capture the entire energy output of its host star. Constructing something like a massive enclosing Dyson sphere brings their capacity up to 10 to the 26th watts. Then there is Type 3. A species capable of commanding the energy of an entire galaxy. That requires an output of 10 to the 36th watts. These aren't steady, incremental steps. This is a logarithmic scale. A Type 2 civilization produces 10 billion times more power than a Type 1. A Type 3 produces 10 billion times more than a Type 2. True cosmic advancement requires engineering at stellar scales. It makes our current definition of high-tech look like children playing with wooden blocks. So, looking at our global power grid, where exactly does humanity rank on this metric? We don't. We aren't on the primary scale at all. Humanity is a Type 0 civilization. Carl Sagan later extended the scale to include decimals. Based on our current global energy production, humanity sits roughly here, at 0.73. The math is rigid. And the reason we score so low is simple. To generate the vast majority of our power, we still rely on burning fossilized biological matter. We dig ancient, dead plants out of the crust and set them on fire. Setting fire to biological waste to generate electricity captures a tiny fraction of its potential energy, marking our primary power source as crude in efficiency. We may have split the atom and built the internet, but our civilization is still anchored by an engine of crude carbon combustion. We are stuck below the first rung. Humanity's Type 0 status reflects our position in a cosmic infancy, but this specific stage, right around 0.73, is exceptionally dangerous. We have just enough technological capacity to permanently damage our own biosphere, but we lack the engineering mastery to control or stabilize it. The transition from Type 0 to Type 1 acts as a high-pressure bottleneck. It functions as a universal filter, testing whether a young species can outlive its own rapid growth. Reaching Type 1 depends on scaling our infrastructure to encompass the entire globe. Consumer electronics will not bridge the gap. Only sustainable planetary engineering can meet the physical requirements of the scale. We spend a lot of time obsessing over faster processing speeds and building virtual worlds. But the universe doesn't grade on software. To cross the Type 1 threshold, we need physical breakthroughs. We have to master commercial nuclear fusion or engineer methods to capture total, efficient solar output. And harnessing energy at that magnitude is mathematically impossible without unified global resource management. This is the true proving ground for our species. We either figure out how to step onto that first rung, or we fade away as a Type 0 anomaly, buried deep in the crust of a very quiet planet.